Okay, so we got all of our tools ready, got our outlets set up, got them wired in the boxes, got them wired to the relay boards in the back, got the hot wires connected and all that sort of thing. Then we got our box built. Next thing we're going to do is take the inside panel, set our gang boxes, 4 gang boxes, 2 gang boxes, whatever size. Your outlet boxes go inside there. Now what I'm going to do is take a number 2 screwdriver, or I'm going to use a number 2 screwdriver and a drill. Just take your time with it. You don't want to strip those screws out, don't want to break those little tabs off. What we're going to do is put right there and all around where those little tabs are. We're going to come up and grab hold of the back of this board, and since when you do that, it's going to attach that gang box into the board. Okay, now that I got all those done around the box, I'm going to put all the boxes in, set those tabs, and I'll get right back with you. Alright, now I got all the boxes mounted. All the tabs are out on them, locked in place. The next thing I'm going to do is I'm going to mount my Arduino. Right in this little area here, you can tell we had the marks where we did all the cutouts and stuff. And what I have here is a 3D printed mount for the Arduino Mega. I printed this out on my 3D printer. I'll leave the a link to the file in the description box below, so if you want to print one out, you can do the same. I'm going to just set it right about like that. My cord's going to come out, my USB cord's going to come out, and through that hole there, like we talked about in the previous video, so if I need to adjust the program in it, so on and so forth, it's easily accessible. So let me get this mounted. Alright, I got this mounted. I just got it lightly screwed on there, just enough to hold it in place. You don't want to warp it or anything like that. Now, you don't have to use a mount like this. You could actually mount the Arduino with these little mounting holes they got. There's 4 of them. You can do it just like we did the relay boards. Same size screw. You can put spacers on it, but you're going to have to probably drill through your board. If you use a machine screw, or if you find a small enough wood screw, you can go straight into your board. So this mount right here just slides in place. Just be careful, there's nothing holding it in. On this side, I may put a little screw or something in here to keep it in place. Okay, now we got our boxes set in, got our Arduino in place. Now next thing we're going to do is going to connect the Arduino to the relays. Now if you remember in one of my previous videos of building this box, I have a sheet. It tells me what is what, where it goes, how many lights are in there, pins and plug numbers, so on and so forth. Now, I'm not sure if this is going to pertain, or how it's going to pertain if you're going to use Vixen. I'm not exactly sure. I haven't fooled with Vixen enough to know. I'm sorry. I'm hand programming mine. It's been a long process. But the principle is still the same way of wiring your Arduino to your relays. There's 2 ways to do it. You can use what's called, they call them jumper wires or DuPont wires. They have them where there's male on one side and female on the other side. And of course, it's not going to focus. Or they have male to male, so on and so forth. They got them in different lengths. Now I need 52 of them. They're not expensive at all. But what I do is I went and got me a roll of 22 gauge solid wire. I got it off eBay for I think it was $6-7 maybe. It's a 100-foot spool. So what I'm going to do is cut my links. Start my first relay and go all the way down and cut the link, strip it down, set it inside. So here you can see where I have the trigger wire that's going to go from the Arduino to the relay. This is channel 8 of the relay, but it's going to turn on receptacle 1. That's why we made the sheet that tells which relay turned on which outlet. I got it ran down the side. And I got some slack on it because I'm actually put some connectors on here and keep all these wires together and make them look a little bit nicer and neater. Got it ran all the way around here to Arduino. Now whenever you cut your wire for your trigger wire, it's only about a 1/4 inch, maybe not even that much. But when you put them in there, they just snap in place. And what you want to do is, you can see here, this is one of those DuPont wires. That's about as much as you want to strip off your wire on both sides for your Arduino and for your relay terminals. So I got 54 of these to wire up. This is going to take me a little bit. As soon as I get done, I got to get back with you with the next step. So I got my first relay board there wired up with the trigger wires. Now one side, 4 of them I went to the right side of the board, and the other 4 I went down the middle of the board. They all connected to my Arduino, to the respective pins on my diagram that I made. Now right now this wire is a mess. This is just a real rough end wiring. So what I'm going to do is I'm going to pull each one off the Arduino here and shorten them up and make it look a little bit nicer and a little bit neater, and I'll show you something else I do with them, make them look nice. So the first thing I did to get these wires straightened up and cleaned up and a little bit nicer looking, I installed these wire clips down the sides and middle here. And I 3D printed these. I'll leave a link in the description so you can print your own. You can buy these at Walmart. I know Lowe's has them, Home Depot has them. They're not expensive, but I got a 3D printer and I can print 12 to 14, 15 out at a time easily. In whatever color I want. Color doesn't matter, just whatever I had in the printer at the time. So now I'm going to pull these wires out of the Arduino, shorten them up and get rid of all this mess right here. Okay, I got the wires all cut down a little bit, shortened up. As you can tell, there's not so much of a hot mess, a little more organized. And I got some more of the cable clamps in place. Now I can continue on wiring all these relays up. It's going to take me probably the rest of the afternoon, so I'll get back with you when all that's done with. Okay, so I finished up all the wiring of the relays to the Arduino. Now I previously mentioned that I ran the wires and then shortened them up. Well, here's another thing I suggest. Instead of doing that, actually making them the right size the first time. Instead of going back and cutting them, go ahead and cut them close as much as you can at first. Here's why. If you look right here, this was a 100-foot spool of that 22 gauge wire. Look how much I have left of it. That's probably, if I'm guessing, 5 to 10 feet, if even that. So I used almost 100 foot of wire in here. These little cable clamps, they did pretty well. It still could use a little tightening up, and obviously here where the Arduino is, it's a rat's nest, but it's in there. It's secure. I've still got to put another screw or something. It's not going to slide out, but you know, just my OCD kicking in again, I guess. So now what we're going to do is we're going to actually power the relay boards themselves. They each need 5 volts. If you look right over here after we connected all your lines, right here you have a negative and a positive. And you can also do it right here. Now if you're just going to use one of these boards, maybe 2 of these boards, you can actually power it off your Arduino. The Arduino has 5 volts and a ground. And it gives you enough current to run 1, maybe 2. But since I'm running 7 here, I'm going to actually power them via a USB, not USB, a wall wart, a AC/DC adapter. So here's what I have that I'm going to power all those relay boards with. This is a AC to DC adapter. It takes 120 volts and it puts out 5 volts at 2 amps. Now it's not going to give out full 2 amps all the time. That's what it can give out. This is going to give out what the Arduinos are, the relay boards are asking for. I forgot how much they each need. It's not a whole lot. This is actually about a ½ amp or so more than I need for the whole setup. So what I'm going to do is I'm going to cut this end off, and there's 2 wires in there, positive and negative, and I'll show you the difference here in just a minute as soon as I get this cut off. And I'm going to connect it to the first relay board, and I'm just going to daisy chain it all the way around till I get to the end. And I'll show you how to do that. So here I've cut off the end of it, And inside of this wire coating, or this vinyl coating, whatever it is 2 wires. A red, it's going to be your positive, and black, that's obviously going to be your negative. Now I stripped off the coating about 3-4 inches, just give me enough room. And what I'm going to do is I'm going to connect them in here to the first relay, and then I'm going to take some wire and go from that one to that one to that one, so on and so forth, until I basically daisy chain them all together. Okay, I got everything wired up. It started raining on me, so I had to bring my work here underneath my back patio, and my back patio is a mess because my shed blew away in the hurricane. Anyways, go from our wall adapter, AC to DC. Make sure your adapter puts out the right voltage that your relays need. These relays need 5 volts, so make sure your adapter puts out 5 volts. Don't give it any more, don't give it any less, give it what it needs. Your red and black wire comes off your adapter into your plus and minus side of your relay board. And then I have these red and white wires that do the same thing, go from positive and positive, negative, negative, and I just what's called daisy chain them to every single one of them, okay, to the end. Now what I used is this right here. This is a 18 gauge, what's commonly known as bell wires for doorbells and buzzers and stuff like that. It's actually 2 different wires just twisted together. That is 18 gauge. It holds enough current. That wire is capable of holding about 5 amps, and we're not even going to push 2 amps, so it's plenty. Now you could actually probably get away with your trigger wire, the yellow wire, but it may not be enough current handling. So I went with the 18 gauge wire. You can get a 25-foot spool of it from Lowe's for about $5. It's very expensive, and it has your red and black, red and white. So your red can be your power, white can be your ground. Keep everything organized. Now, the one problem with that is, if you remember, excuse me, these yellow trigger wires, they're 22 gauge. This red and white wire is a 18 gauge. If you put those in the terminal together, the smaller yellow wire is not going to get crimped down on by the connector. Now, what are we talking about? Well, if you look, I have this brown wire coming off of, and of course it's not going to focus for me, but anyways, it's coming off the negative side. This is DC negative of the relay board, and it comes down back to the Arduino to a G and D pin, which is ground. Sorry, my camera's not focusing right. There we go. It is attached to a ground pin, G and D. Make sure it is on a G and D, not a power 3 volt or 5 volt. Make sure it says G and D. Okay. I'm sorry it's not focusing, but and what that does, it actually grounds everything connected together. Grounds all the things together. So if we're at one point in your show where all your lights are on, every one of these relays is on, it's going to make sure there's enough power and enough ground to keep the Arduino running and keep the relays running all at one time. Okay. Now what I'm going to do is I have a power cord. It's a 3-prong. I think it was an old extension cord or something off a tool anyways. It's a 14 gauge wire inside, 3 14 gauge wires, green, black, and a white. It's very handy because now we're going to connect all the powers to the outlets in the box. Okay, I'm going to use the same connectors like that is right there. There's Wagyu or Wagyu, whatever, the same connectors. But I'm going to connect all these black wires. I'm going to have to run a black wire from each one of these connectors, and then I'm going to connect it to the black wire of the cord. Then I'm going to do the same thing with the ground. I'm going to connect all the grounds together using the same style connector, a different connector. You keep them all separate. Keep your black and white and ground, or excuse me, your black, white, and ground. Yeah, black, white, and ground. Keep them all separate, obviously. I'm going to connect all the grounds together, and then I'm going to connect it to the green wire of this extension cord. And then I'm going to connect all the white wires the same way, using the same connectors, all the white wires together. And I'm going to connect it to the white wire. And then theoretically, if everything is connected together, every terminal is tight and taut, and we all wire this together, it's going to turn on as soon as we plug it in. So let me get working on this, and I'll show you how it looks when I get done. Okay, so I have all the wires coming off our main power cord connected. All the white wires are connected. And there's daisy chain to this section here, and all the white wires are connected there. All your hot wires, the black wires, all those are connected, coming off each box. And then in between those goes another one that goes to each box. All ties back into the black wire of the power cord or the extension cord. Then the ground, green's for ground, comes up, and that connector there ties off to that one, that one, as a jumper wire, connects all four of those together. Now all the outlets inside are wired up, all the relays are wired up, all the relays have power. Now we're going to need to power the Arduino. Now the Arduino, I got the kit, the little kit that came with this power adapter here. And this one is a 9-volt, 1 amp. It's plenty enough to run it. Okay. And it has this little barrel jack. Oops, excuse my finger. It has this little barrel jack, and it just plugs into the power port. Just presses right in, no problem. Alright. Now I'm going to go ahead and take my USB cord. I got a 3-foot cord off of eBay for $3-4 off a US seller. I'll leave a link down in the description for that. Like I said before, that long cord helps me if I have to adjust my program. I don't have to take this whole board out of the box. I just run it through the hole here. Okay. So now we have a power adapter for our relays. We have a power adapter for the Arduino. And we have a power cord to power the outlets. We need something to power all of those together. Okay, so this is how we're going to power everything up. I have this power strip I got from Lowe's. And I got one with a 6-foot cord on it. It's dirty. I used it last year. I'll clean it up later on. It works great. That 6-foot cord gives you a good length of distance. You can have your plug or your box away from your outlets. Anyways. So we have the power cord that powers all of the outlets plugged in. This is the AC to DC adapter for the Arduino. Now I had to change styles. This is the one I originally was going to go with, but if you look at the way the plugs are, the receptacles are, everything, they would be stacked on top of each other and pressed on top of each other, and putting that cord in the bind wasn't going to do all that. This is the same voltage, the same amperage, same everything, just a different configuration of the plugs. It's the one I used last year in my small box. Still works fine. And here is the outlet that powers the relay boards. So I'm going to plug this in and flip the switch, and hopefully we don't let the magic smoke out and everything goes good. Now, if you're unsure, this is a good tool to have. If you're unsure, when you plug it in, have your finger on this outlet, your switch right here. So if something goes wrong, you can flip that switch really quickly to shut the main power off to everything. Okay, and you know, I definitely probably suggest doing it outside as well too, just in case something went wrong, something's loose. Just safety precautions. Okay, so I'm gonna get plugged in and wish me luck. Okay, got the power strip plugged in. Everything's hooked up. Looked at my connections, everything looks good. Let's flip the switch and let's see what happens. There she goes. Now I've preloaded my program into the Arduino. It's going for its test sequence. Turning on the relays and sequences. No magic smoke coming out, no sparks, no arcs, No funny noises. I think this turned out right. So I'm going to go ahead and get this mounted inside the box. And we're going to start putting on some lights. Okay, got the panel ready to go in the box. Got the cord ran for the hole in the bottom of the box all the way out. And this is just going to set in there. And I'm going to screw it in from the side. And it should be ready to go. Bring it out to where I need to put it at. Start hooking up my Christmas lights to it. Alright, so I got the panel mounted inside the box. I just got 2 screws on each side just holding it in there. Just in case there's something I have to go back in and fix or adjust or something like that. Now we shouldn't have anything to adjust or fix because I tested it outside the box and everything seemed to work quite well. As you can tell there on the bottom, I have that hole cut out for my USB cable. I think that's going to come in handy because if I want to change a program or something like that. Anyways, I'm going to set this up on probably 4 bricks or maybe a center block or 2 so my extension cords can come out of the hole there and come down and out to where they need to go. Now, if you notice, there's no wall plates on this, or cover plates. If you go to Lowe's or Home Depot, you can order them. They don't carry them in stock because putting 4 outlets in a box like this is not something a residential person is usually going to do. They do make the outlets covers for them, but they're about $12, $13, sometimes $14, $15 a piece. And I'm looking at 4 outlets. That's going to cost me $60. That's not going to happen. So I actually found a 3D printed file online, and I got a buddy who's actually going to print me out these in a PETG that's going to last really well in the weather, not warp or anything like that. And they'll be here in a couple weeks. I appreciate them taking care of that for me. And I actually have one I did for the 3 gang box on the bottom of my printers. Just a little bit too small to be running the 4 gangs. But anyways, I think it turned out quite well. It's going to work out quite well. And let's hope the light show turns out well and everybody enjoys it. The box turned out quite well. Turned out really well, I think. Appreciates everybody's help that's helped me along my way building this box. Appreciate my fiance for not losing her mind with me. My Christmas light session and all the time I spent doing this here and there. Our daughter's helped us out a little bit here and there. She's my supervisor of the Christmas lights. Tells me where to put them at and all that good stuff. So, but anyways, I think it turned out quite well. Now, I'm not sure if I'm going to do a video on how to program the Arduino. Like I said before in my previous videos, I am hand programming this. It's not to music this year, and it's taken me about 6 to 8 months to hand program it the way I wanted it to. I do not suggest hand programming if you're a beginner. Definitely don't suggest it. There's a couple programs you can use like X-Lights and Vixen. I suggest looking into Vixen. I'll put some links in this video, my next video, on some good videos on how to program Vixen to your Arduino. But I'll probably do a little short video on how I did it the old school manual way.